Hello everyone. This is very interesting question. There is an op-amp, and in the question we have given that bias current, input bias current are flowing in the op-amp, which is 12.8 nanoampere, and we have to ask about that what is the offset voltage due to this bias current. So before solving this question, I will explain what is the bias current, input bias current actually. Mein. Uh, like in the real system, op-amp is not an ideal op-amp. So in non-ideal op-amp, there is some normalities, some non-idealities, which will result in some error voltage and some in offset voltage at the output node when there is no input. Means there is two kind of uh, two kind of normalities, which is first is offset voltage. Means there is an offset voltage at one of the inputs of the op-amp when there is no voltage. Like I will explain on the paper. Like there is an op-amp. Okay. Uh, if there is an op-amp and we are not applying any output here, we are not applying any output here. So we input is zero and this voltage is also zero. And at output side, we are assuming that we will get a zero voltage, but in reality, this will not happen because there is some offset voltage at positive input, sorry, negative input or positive input or both input. So this voltage is called offset voltage. Means this voltage results in when there is no input, and there is no AC input, and we bias the circuit properly, VCC minus VCC. Then if there is no input, no differential voltage, then we will get a output voltage, which will eventually saturate it as standing. This is a simple concept, offset voltage concept, and uh, and there is another normality, no ideality we can say. It is input bias current. What is input bias current? Offset voltage, there is an offset, but in input bias current there is not no offset. There is a by input bias current which are flowing outside of the terminals of the op amp, because op amp has no infinite input resistance at all. There is some finite resistance. Due to this, uh, input bias current are uh, flowing outward from the terminals to the op amp. Let me draw. Then we will. Okay. No, not that. Yeah. So, input bias current, input bias current. What is this input bias current? There is some input bias current flowing in the circuit when there is no input voltage. When there is no input, and we properly bias the circuit, like this is op amp. This is op amp minus plus, and there is one uh, hmm, IB1, and one resistance are connected here. One resistor are connected here. And actually it's not positive, it's negative terminal, and this one is the positive terminal, and a resistance is connected here, and this will form a negative feedback loop of the system. And this is R2, this is R1, connected to the ground, and this one was the IB2, not IB1. This one was the IB2 current, IB2 input bias current, and there is one another input bias current which is IB1, and there is input, and we can say V. Okay. and this is V out. Uh, and for the time being, when for the input bias current, we will assume that V input is zero, V in is zero, and this IB1, this IB1 has no effect when V input is zero, as it is ideal and there is no resistance and not nothing at all. So, and this is ground. So this IB1 will not affect the circuit, but this IB2 will affect the circuit as the as the as V input is zero and system is in negative feedback, negative feedback. So we can assume virtual short. I know this is not an non ideal op amp, but it's not completely non-ideal. We just consider this non-ideality. Rest gain is high and input gain is high. So we can assume that we can assume the virtual short. We can assume virtual short here, and if this voltage V in is zero, so this input is also zero. So this terminal or not input, this negative terminal is also zero, means it is on ground. So if this is on ground, then this resistors, both terminals will be ground. So this resistance has no effect on the circuit, so we can neglect this R1. All the current will flow in this R2 to IB1. Okay, meaning there is no current in the branches of the op-amp, like we are assuming that op-amp is ideal for the time being, but there is non-idealities which we are seeing. So no current is flowing in this branch, and all the current will flow in this resistor to uh, this current source, which is IB2. So IB2 current will flow in this branch IB2. Due to this, there is a voltage drop occur on the circuit, which is the voltage drop across the resistor is R2IB2, which is V out voltage. So we find out that output what is offset voltage due to bias current. So offset voltage due to bias current IB2 is R2 IB2, or this is our offset voltage. Okay, and there is a correction method to compensate this offset voltage. Uh, what is this? Leave it. I will explain this later some other time. So go back to our solution. So in our solution, they ask us to find out the bias current, offset offset voltage due to bias current. So we find out that offset voltage R2 IB2 IBT2 R2 IB2, which is this offset voltage. So V out is R2 IB2. So R2 is in the circuit R2. This is R2. R2 is 98 kilo ohm, 98 kilo ohm, and the IB2 is IB2 IB2 is 12.8 nano ampere, 12.8 nano ampere. And if we solve this, we will get this 1.254 millivolt, 1.254 millivolt offset voltage. This is our final solution answer. So I will also explain this correction method then. So the correction method for compensate this offset voltage, engineers add a, a parallel combination of R1 and R2, parallel combination of R1 and R2 at input side R1 R2. This will go to the positive terminal of op amp plus minus, and there is there there is one IB1, there is one IB1, this is ground, and this is V in, there is one IB1, this is ground, and this is V in, and this is IB2 voltage, this is R1 R2 R2 R1. Okay, so this is a correction method to compensate this R2 IB2 offset voltage. And one other thing is that this IB1 and IB2 are very small, so they are very similar or same in magnitude. So if we and uh, when we in zero, all the IB2 IB1 current will flow from the combination of this circuit. So combination of these resistors. When V in zero, all the IB1 current will flow from the combination of these two resistors, which is R1 parallel R2, and due to this, there is some voltage drop across this positive terminal. So if we apply the superposition theorem, if we only consider if we consider this voltage drop first, like uh, V positive R. This is the parallel combination of R1 parallel R2, R1 parallel R2, which is an IB1, which is negative in magnitude as the current flowing from this direction to this direction, and this is 0 volt. Means this is on the ground. So there is a negative voltage appear on this terminal. So first we will consider this voltage. Due to this voltage, the output voltage uh, and this is ground, this is positive voltage, the voltage appears on the positive terminal, so it will act as the non-inverting amplifier, and we will get 1 plus R2 by R1 and plus first I'm direct writing the equation. This is when we consider positive terminal voltage, and when we don't consider positive terminal voltage, which is if we consider this as 0, there is then the process repeat, and we will again go back to this circuit. And due to this, we already found out that offset voltage is R2 IB2. So I am writing this R2 IB2. So uh, after after expanding this equation, I am getting IB1 R2. I am getting R1 plus R2 by R1. If you solve this, you will eventually get to this equation, and this will cancel out, and this is R2 IB2, and we will get IB1 R2 plus R2 IB2. So it will eventually cancel out, and uh, this is V out, and this one is the positive terminal voltage when we are considering using superposition theorem. So this is V plus and this is V out voltage. Okay, and this is when V plus is off and the negative and the V 0. Okay, so eventually V out is 0 volt, and how this is happens due to this combination of this parallel combination of R1 and R2. We will take this as same as R1 and R2, and eventually the voltage offset voltage which are creating by IB2 is cancelled out by IB1. Okay, that's how we correct the and that's how we eliminate the non-ideality from the circuit. Thank you. I hope you like my solution.